Hi, welcome to ElimuHub. This is an introduction to Venn diagrams, and the objective is to be able to construct a Venn diagram, and we need to be able to calculate probabilities from events occurring using Venn diagrams. So the first thing you need to know is notation when we do Venn diagrams. Well, obviously, this is probability of A, for example, event A. We need to know if we have probability of A and B. So this means both A and B must occur. So A and B, okay? And if we have P, probability of A union B, then it means A or B, probability of A or B. So this is called intersection. A intersection B, it means A and B must occur. A union B, it means A or B is allowed. And you need to understand probability of this. When we have a dash, we say A complement. That means probability of A not happening. So A complement means not happening. So these are the most things that you need to know. We also need to know this symbol. It means is a full set, so universal set, and that contains all the elements of what you're looking at. All right, let's do some examples. So we have here A intersection B, and we're asked to shade the region that represent A and intersection B. So this symbol means both A and B have to happen. Where will that be? Well, where they intersect. So this is A and B. Shade the region that represent A union B. So union means what? Both are one or the other. Okay, so they can both happen. It means all this region, all the way. Everything that includes A and B. Shade the region represent A complement intersection B complement. What does that mean? A is not allowed and also B is not allowed, which means we are left with the region that's just outside these two circles. Okay, shade the region that represent not A but B is allowed. Okay, so A is not allowed but B is allowed. So what would that be? So anything that's not A but can be B. So anything that's not A is outside to start with. So it's allowed to be in B or B. So that means we can have people in this area here. Okay. And the last one, shade the region that represent A intersection B complement. So what does that mean? Well, anything that's in A but is not allowed to be in B. So A is allowed but B is not allowed, which means it is just that area here. Right, now let's do a quick example. A card is selected at random from a pack of 52 playing cards. Let A be the event that the card is an ace. That should be just N, not D there. And D is the event that the card is a diamond. And we're asked to find these probabilities. So let's just draw the Venn diagram to start with. And we got 52 cards. And how many aces? So there are 4 aces in a pack of cards. And diamonds, how many diamonds are there? There are 13 diamonds. Okay, so the first thing you need to do is draw the two circles. They are going to intersect because there's a card that is an S, but is also a diamond. So we must have an intersection. And then we must draw this rectangle. And then we put our symbol there to represent everything that is in the full set there. And one side we have aces, and the other side we have diamonds. Right, so there's one card which is an S and also a diamond. Okay, so that goes in the middle. And then we have 4 aces altogether. We have one that is already there, so that means we're going to have 3 here. We have 13 diamonds, but we have one that is an ace of diamond. That means we have 12 here. Now don't forget what is left. We have 52 cards. Where will they go? Well, they go outside of the circles because they're not aces and they're not diamonds. So 52 take away what we have here, you'll have 36 cards outside. Right, what's the probability of getting A and D? So we said A and D is A intersection D, which is the middle part. There's only one card. So this one is 1 out of 52. Right, what's the probability of A or D? What did I say O means? Is union, right? So that means it could be A or a D, an ace or diamond. So everything inside the circles. So 3 plus 1, 4 plus 12 is 16. So that is 16 out of 52. You can simplify that and get 4 out of 13. What's the probability of not getting an A? So anything that's not A. Well, anything that's not A is 12 plus 36. Well, if you add that, you will get 48. So anything that's not A is this one, 12 plus 36, which is 48 out of 52. And what do we get? That is 12 out of 13. Now, what is the probability something is not an ace, but it is a diamond? So we don't want something that's an ace, but we want it as a diamond. Well, there's only 12 of them. So it's 12 out of 52, and that will give you 3 out of 13. Right, thank you for watching, and please subscribe and like the video if I have helped you today. Thank you.